Abu Dhabi's civil defense stations use dashboards to track operational performance. A station commander might look at a gauge like this and report that their crew reaches emergencies in 6 minutes on average. This average must account for the physical variables of the city, such as a dispatch truck navigating heavy gridlock at a congested intersection. It also includes the time lost when a crew is routed to a wrong address and has to correct their course. While an average provides a high-level summary, it can mathematically hide the specific long-duration delays that occur during a shift. For these reports to be useful to leadership, the underlying raw data must be structured, filtered, and verified for accuracy. Every physical action, from a ringing fire alarm to a truck leaving the station, is recorded as an individual data point. Pulling a raw incident log for a station results in a table containing 1,000 rows of recorded events. We will deconstruct this specific ADCD incident log to isolate the performance indicators and apply audit standards to test the data's reliability. This log provides a technical record of how a station performs across every recorded dispatch. To verify a response time claim, analysts organize the log into 2 distinct data families. Qualitative data includes non-numerical identifiers, like alpha law or high-rise fire. These tags allow grouping. Quantitative data consists of measurable numerical values, like 12 firefighters or 6.4 minutes. Accuracy depends on keeping these types separate. You cannot calculate an average using descriptive tags, and you cannot group incidents effectively without their qualitative context. Quantitative numbers are divided further based on their mathematical properties. Discrete numbers are whole, countable values used for items that cannot be divided into fractions. You can dispatch exactly 3 fire trucks to a scene, but you can never dispatch 3.5 trucks. Continuous numbers are values on a sliding scale that can be broken down into decimals, such as a stopwatch recording 6.42 minutes. Emergency reporting relies on precision. Rounding a 6.42-minute response to a flat 6 minutes removes the detail needed to identify small but recurring delays. We can now apply these concepts to the 1,000-row spreadsheet. Sorting arranges a continuous data column in sequential order. By sorting response time from slowest to fastest, we see how individual rows compare to the mean. A 15.2-minute response time moves to the top, an outlier representing a significant deviation from the 6-minute goal. Below it sits a 20-minute response. While the average might remain near 6 minutes, these specific rows reveal where the station's performance hit significant bottlenecks. Filtering isolates specific variables by hiding unnecessary rows. By filtering the station name column, we focus exclusively on Alpha Law Station. A second filter on incident type lets us look specifically at how that crew handles elevator traps. Sorting identifies the outliers, and filtering isolates the variables. Together, they reveal the specific performance trends that an average summary might miss. It is important to distinguish between a simple count of activity and a specific performance goal. A metric is a tally of actions, like 120 safety checks. It tracks volume, but not effectiveness. A key performance indicator, or KPI, is a measurable value tied to a standard of success, such as ensuring 98% of high-risk buildings are inspected on schedule. To evaluate speed, management must move past general questions and set a strict KPI, like the percentage of responses completed under 8 minutes. KPIs provide the specific targets needed to evaluate operational outcomes, rather than just tracking the volume of activity. Before a KPI is reported, the underlying data must be checked for quality. Data quality is measured by accuracy, completeness, and timeliness. This is a requirement of IIA Global Internal Audit Standard 13.1, which focuses on work information reliability. Auditors following Standard 13.1 look for completeness issues, such as nulls, which are entirely empty cells in a timestamp column. A single missing timestamp or null prevents the calculation of a response time for that row, which in turn makes the average response time for the entire station mathematically incorrect. Using a dataset that contains nulls leads to performance reports that do not accurately reflect station operations. When nulls are present, the error propagates through the data. This invalidates the continuous data and makes the final KPI calculation and the commander's 6-minute claim unreliable. Classifying and validating logs is a technical prerequisite for accurate operational oversight. Maintaining data integrity serves as a primary control for the Abu Dhabi civil defense. Clean, unmanipulated data ensures that leadership can pass structural audits and make decisions based on the actual facts of their emergency response.